Hello, everyone. Welcome to our beginner-friendly system design series. So the goal, before we get started, I just want to um, provide a quick overview of the series. So essentially, the goal of it is to help you get started with system design on real life app examples. So during each event, we'll talk about how to build a certain app from scratch from the system architecture perspective. So we'll not have any coding, just conceptual overview and walkthrough. And also each event is going to have 5 core app features that we will discuss. So today's event is called How to Build Netflix from Scratch. And we are going to cover 3 core app features. The first one, video storage and streaming, then recommendation engine, and then personalized content generation. And we will have a few events in the series, as I mentioned, and the next one is going to be in a few weeks. So we'll post the details soon. And also, we want today's session to be as interactive as possible. So feel free to drop your questions in the chat and we will answer them live. And I think, yeah, but now I want to introduce you to our today's speaker, Faisal, who is a Google developer expert and a CTO at Irene. So thank you so much for joining us today and take it away.
Hello, thank you for having me. So yeah, I'm back by popular demand. We did a WhatsApp one, and I really enjoyed doing that. So thanks to back and I talk about Netflix. Um, it's fun to build Netflix. It's not fun to watch it because it's a big waste of time. But anyways, we'll learn about how we can actually build Netflix. Not like Oleg said, we're not trying to write code because really coding, and this is a grand theme of the year, with AI and all of that, our engineers becoming irrelevant. And it's if you're just focused on coding, then chances are you will become irrelevant in the next couple of years. What's important is you have to understand how systems are built. And as part of that, I think it's really easy to pick up on how systems are built if you learn how something that you use every day is built. Last time I did WhatsApp. This time we're going to do Netflix. And hopefully by the end of this, you can start to kind of unlock how things are built, how things are architected. And then the coding is just, either going to ChatGPT or Cursor or one of these models and learning the syntax and then just writing the code. That's like the 20%. The 80% really is understanding how something is built, how to architect it, how to think through problems. The rest of it is a lot easier. So we'll do what we always do, and we'll start off with one of my favorite tools called Miro. And so I'm going to share my screen, and we're going to learn how to build it. So I'm going to move you to my main monitor, and now we're on the second monitor. Okay, so we have Netflix here. I took a screenshot of my Netflix homepage, some movie called The Union, which is probably going to be garbage. And then we have a great movie here called The Matrix. And so the whole purpose of this is how do we build something like this, assuming it was built on Google Cloud and you were building it uh, not for scale. And what I mean not for scale is whatever we build today is going to work for a large amount of scale, probably like 10 million users. Um, it will not work for a billion users, right? Because when you get to that level, a lot of things you have to think about very differently. And not that this architecture you just throw away, is that you have to really start to optimize a lot of things. And so a lot of developers kind of get hung up on this where they look at tools that Facebook's using or Netflix is using and all these big FANG companies, and they go, well, maybe I need to use Cassandra in my database or as my database because if it's good for Facebook, it's good for me. And chances are, it's not. What's good for Facebook, what's good for Google, what's good for Netflix is not good for you. Your application is small. Hopefully, it grows more and more. And when you have 100 million users using your application, you probably have hired a bunch of other engineers who have dealt with that type of scale, and you can invest in tools like Cassandra. I'm just picking on Cassandra, but that's the first thing that comes to mind. But you can invest in those expensive tools. But right now, we're thinking about how do we actually architect it from a systems principles. So let's start off by thinking about, like, what was the first thing we were going to work through?
Yeah, I guess the first one we can cover is like video storage and streaming. So
Exactly.
yeah.
So let's start off here. Let's talk about how video streaming. How would you do video streaming? The simplest way would be, you have your application here. So this would be, let's just say, web app, right? And you would say, well, video streaming sounds straightforward enough. I'm just gonna move this, zoom in 100%. Okay. So you might go, hey, video streaming sounds good, easy enough. So web app. All I gotta do for my video is store it in a bucket. And we're assuming we're on Google Cloud, but these principles apply to really any cloud. They're all the same. So here we have a bucket. Now, what's a bucket? A bucket basically is where you can store files. It's like unstructured. You have to create the files. You have to create the folders yourself. I mean, it's like imagine a hard drive living in the cloud. What's nice about a bucket is you can read write to it pretty fast, and it is by default multi-regional, so that if US East goes down, then at least you can still access your files. But all that to say is that's straightforward enough. And you might say, well, that's easy. I can take my little MP4 file. So let's just grab a poster for the Matrix. And let's just use this poster. Right. So you might say, great, I can take my Matrix movie. Here's my movie file. And I can just store it in a bucket. And that's it. Congrats. I've built out my interface. And there's like a library I can download. There's a problem. The problem is a bucket is not designed to stream video content. A bucket is also not designed to properly deal with a lot of issues you deal with when you are streaming video, such as video caching, file formats. When even content, not file formats, quality formats. When you're watching Netflix or YouTube, and suddenly it goes to like really crappy quality, and then really good quality, and really crappy quality. Like, it's not designed for any of that. It's just designed to store a file, and you're downloading the file. It also gets very expensive if you're serving like a 5 gigabyte file, because what a bucket is doing is the web app's going, hey, I want to watch the Matrix. The bucket's going, all right, here's the Matrix. And it's literally just giving you the entire file, right? But that's not what you want, because what if the user stops halfway, right? Then you've just sent over that entire file, all that bandwidth, but the user kind of stopped halfway. And so what you typically do is you have to use something called a content delivery system. And another reason why I use a content delivery system is this user is in Canada. This bucket is in US East, or say the US region. Now you have a second user somewhere in web app India. Let's say he's in India. Now you have an Indian user, and they want to watch the Matrix also. So they're going to try to talk to the Matrix. But the problem is, Matrix itself, they're not trying to talk to the bucket. The problem with this is this bucket is right now in US East, or let's just say US, right? So now it might take, say, 10 minutes for this US user to download the Matrix. Let's assume we're just using the bucket. But it's going to take this Indian user, even though if they have really fast Wi-Fi, you're literally going to the other side of the world to download a file. It's going to take them, say, 30 minutes, and it's going to go download, and it's going to be expensive for you as well as a storage bucket. And so what you do is you create something, basically, you create a pipeline. And let's start off with the simplest pipeline first, and then we can start to make it more robust. So what you essentially do is you have a bucket and you keep everything in buckets. So everything's still going to live in a bucket, which is totally fine. That's like where you're going to store all your files. But you introduced a CDN in front. We're going to call this CDN, and we're going to call this CDN. It's the same CDN. Let's assume they're all the same. I'm just because I don't know how to draw a weird L shape, we're just going to call it that. So look at that. That's the CDN. Your bucket's going to live behind the CDN, and the web apps are going to talk to the CDNs. CDN stands for Content Delivery Network. And Google, my Google Home went off. Google, Amazon, Azure, Akamai, Cloudflare, all of these guys have gone ahead and created CDNs. And what CDNs do is they cache your files across the world, but also at edges. And this is a very interesting thing to think about. When you talk about caching files at edges, what's happening is you have, let's just do it here. So this user could be in, let's say he's in Hyderabad in India. And then we have, and this is a state in India, I think. Sorry if I'm wrong. And we have another user, let's say they're also in India, but let's say they're in Delhi. Now you have two users here who are accessing the CDN to get the matrix downloaded. What's really cool about a CDN is they instead of this CDN being in India, there's multiple places where CDNs exist on Google's network. And either Google builds it themselves or they rent it out from somebody else. I don't know the mechanics behind buying servers that Google has. But what they've done is they create these CDNs at different, what they call POPs. And so here we have a CDN that lives there, and we have a CDN that lives there. So what ends up happening is when a Delhi user or a Hyderabad user wants to access Matrix, they're actually never touching your bucket that lives in the US. They're actually just making a request to Google and saying, hey, I want the Matrix. And it's going straight to that CDN. And it's going straight to that CDN. Now, what happens basically is this CDN, the edge, will go, say it's the first time ever, right? First time ever someone's requested this video and you haven't warmed up the CDN. And there's all these techniques that we won't get into. But let's say it's like completely cold. No one's ever watched Matrix before in the history of humanity. And this person from India, two people in India want to watch it right now. But what happened is first we would go to the CDN and we would say, hey, I want to watch Matrix. The web app is just buffering right now. So there's like a preloader spinning. It goes, hey, I want to watch the Matrix. And the CDN goes, I don't have it. Let's talk to the other CDN or the other network, like the global one. Well, that guy doesn't have it either. At that point, it goes to the bucket. And when it goes to the bucket, it then takes this file, downloads it to the CDN, and then downloads it here and here, right? Oh, actually, it doesn't download it. Well, yeah, it's going to start downloading it into all the other regions based on your policies that you set up on your CDN. I believe that's how Google CDN operates. And so at that point, what ends up happening is now the next time someone from Hyderabad wants to watch this, they will go straight to their local CDN and the movie starts streaming right away, very quickly. And there's slight differences in how content is delivered. And that's a technicality that we won't actually get into too deeply, but like, it's not like the whole video file's downloaded and then the movie starts. It starts to stream, right? So you have to use something like a media CDN that allows streaming of content versus a file CDN, which is like, you're downloading a 30 megabyte file. It's going to download all at once. Whereas a media CDN, it talks to the video player and says, okay, I'm going to give you files bit by bit so you can start watching it already. But let's ignore that technicality. All we're doing, thinking about right now is a CDN, a content delivery network. Doesn't matter how it works. And so that's an interesting use case. So now what happens is you're getting files really fast. Same thing's happening to the guy living in Toronto and the guy living in, say, Halifax. Same type of functionality. They're accessing their own little CDN pods, and they're all getting access to their version of the matrix, and then it's talking to like some CDN central coordinator that coordinates it all, and then it talks to the bucket. So when all this is happening, it starts to create some interesting problems. And those problems are, well, what happens if you delete the matrix, right? And we're talking about Netflix here, but this is what happens. This is how Facebook Live works. This is how Facebook Live and YouTube Live and TikTok Live, they all work. They're a lot more advanced than this because it's live streaming and you have to deal with latency. But when you're talking about like just videos being delivered, reels and TikTok videos and stuff. Essentially, what's happening is this: there's a CDN at every point in time. But what happens if you have to delete the matrix, right? If you delete it from the bucket, it doesn't mean that it's deleted from these CDNs because the CDNs are caching, right? So this creates a very interesting problem called caching validation, where you have to basically somehow have built-in tolerance that, we're not licensed to serve the matrix anymore. It's going to take up to 2 hours or the next like 20 minutes for it to go and delete it from all the caches when the cache expires. This is actually a very interesting problem because how do you determine when the cache is going to expire? I can say, matrix is very sensitive. And so if the second I don't have rights to it, that minute it should not be accessible anywhere. Like if someone's watching it, I want it to just like stop. Now the problem with that is you have to basically tell your CDN to expire the cache every minute. So every minute it goes, hey, I want to watch Matrix. And if it's after that 60 seconds, it's going to be like, hold on, let me go download it from somewhere. And it's going to download it. You just have to start paying a lot of costs for it. So instead, you have to build in some sort of cache invalidation strategy where you're okay with the matrix still being able to be watched completely if someone's watching it within a suitable time frame. And then that's where you can build in some business logic into your web apps that can say, well, we're not allowed to watch Matrix anymore, so new people won't watch it. And every like 20 seconds or 30 or every 10 minutes, I'm gonna check the server to see if am I still allowed to watch the movie and watch it. Like all that gets very complicated. I'm just throwing that in because that becomes a problem where you might go, well, crap, we accidentally updated Matrix, but it's in Japanese, right? And everyone's getting served the Japanese version of Matrix. And then you go, okay, no problem. I went and I overrode my file, and it's now the English version. The problem is everyone still has the Japanese version cached. So you need to think about those edge cases when you're thinking about CDNs, because otherwise, if you tell your CDN, cache the file for 30 days, and there's no way that the CDN gives you to invalidate your cache, which all of them do, but if you haven't built that tech feature into your application, the easy way to do it, then you're going to get stuck figuring out how to get removed the Japanese version of Matrix from everywhere before you can start serving.
Yeah.
I know you work with the music company. Same problem applies to, right? Like Spotify is doing the same thing with media streaming. They have MP3s CDN littered over. So when I play an MP3 in Toronto, technically it's a different file. I mean, it's a different version of that MP3 than someone in Switzerland because they're accessing a different CDN.
Mm-hmm. Yeah, it makes sense.
Yeah.
I also had a few quick questions.
Yes.
Related to CDN. So it just a side note, someone asks like what CDN stands for. Just remember it's Content Delivery Network. And then
exactly.
One two questions of my own. So country content restriction is how I would call it. So for example, like, you know how different countries like have their own I don't know, set of movies. So right now, like some people just use VPN and then switch like to a different
Yeah.
country. So is this how, like, can CDN control it? So you said policies, right? So would policies be the ones that said, okay, make this movie accessible for those CDNs, but make it accessible there, or how would it be managed?
Um, I think actually it depends on the features of the CDN. There's so many of them. Like Cloudflare has one, but Cloudflare, as far as I know, doesn't have the ability to add geo restrictions to your CDN. Um, a lot of time, let's assume yes, there's the ability to do that. Then yes, you would have to basically put in some ways to control it, but you also have to have that business logic on your app, right? So when your app controls goes and talks to the database, it goes, well, this user is in Canada. Give me all the Canadian movies, and then it downloads a list of all the Canadian movies, right? Before it talks to the CDN, it gets a CDN URL, and so those CDN URLs are also short-lived, and so it's not like I can reverse engineer, grab a CDN URL, and now I can just share it forever, right? So there is policies built into it on how long they can live. That link, it's usually called like a signed link, where a signed link can live for like 20 minutes. And after that, it needs to like refresh. And the way it refreshes, it talks to the backend and it says, hey, can you please sign this link to authorize that this user has access to this link for the next 20 minutes? And on and on. So some CDNs might have geo restrictions. I mean, we could actually Google it. CDN geo policy. Well, it's going to talk about geo CDN. Yeah, right here. How geo blocking and CDN strategy controls. Yeah, so this one, CacheFly, has the ability. Potential challenge geo blocking includes false positives and location detection using VPNs to bypass control. So CacheFly looks like they have some sort of geo blocking in strategy. I don't know if Google Cloud does actually. So if we go to Google Cloud CDN here, so you can see what common use cases: static content, dynamic content, video streaming, large gaming and software downloads. And actually, you can see they have edge caches here. So they're talking about how it's working. So look at this. It's essentially, funny enough, very similar diagram that we made. So you have your web apps here, and then it's talking to the edges there, and then it's talking to the CDNs, the big guys there, and the big guys are talking to the cloud storage bucket. Like this stuff is all, ignore all this, but what's happening is the same thing here. It's talking to the CDN, the CDN's delegating it out.
So by edges, it means like those smaller CDNs that you pointed out on the diagram, right?
Yeah, exactly. Edges are the smaller CDNs. Like think about an edge. It's like, there could be a server in Toronto. And actually, do I have an example of an edge? Maybe actually. So if you go to this website I read, you can actually look at. This is Cloudflare. So this is using Cloudflare. And we don't have video streaming on this site. But if I go to network, I believe, and if I were to hit, say, the HTML page, I can look at in the headers. Yeah, right here. Okay. So this is not cached. However, it's being served from the local YYZ, which means that there is an edge somewhere in Toronto that Cloudflare has where this content is being served from. Now, it's not cached right now, but it's still being served from there. I can find content that's cached here, like, let's see. All these are not cached. I might have some cached. Oh, I know what, a PNG. Yeah, this is going to be cached. Actually, I think this cache control is wrong. I think it is being cached because otherwise it wouldn't be. Oh yeah, there we go. I think this is just this is something else. This is Cloudflare controlling the cache. It's ignoring this. But what you see here is, yes, it cached it from a CDN, and my CDN is in local YYZ. If you were to go on this website and go to Favicon, you can see your local YYZ will be local YTZ if you're in Alberta or whatever Florida is.
Mhm.
It will be that. And so essentially, this is a PNG, but imagine if it was a movie, it would be actually loading it directly from that. It's never hitting my button.
Yeah. And then just a other quick question in terms of, so you brought up an interesting like edge case, I guess, and I was just like thinking in my head how it could potentially be solved. So as you said, like our license expires like in 1 day, let's say, and we need to play this movie so from our system. But then what if the user is still like watching a movie, right? We don't delete it while they're watching the movie, right? So we need to ensure that technically no users are watching the movie when we delete it, correct? So this is
So this is an interesting thing. So technically, when you use a media CDN, something that is specific to videos. So we're getting a bit detailed, but that's fine. What happens is you're never actually serving the entire matrix. What you're serving is bits and pieces of it. So let's do this. So let's cut the matrix up into, let's copy it, let's paste it here. And then let's cut the matrix below here. Copy and paste it here. Okay, well, copy and paste it here. Okay, so now when you are watching the matrix, what's actually happening is the CDN has basically uh, bits of the movie, and it's streaming bits of the movie to you. And this is how you're actually able to control video quality, where it will send you, and these are small bits, like let's assume it really depends on the provider, but let's just assume they're all 1 megabytes, right? So a 1 megabyte of matrix is streamed to you. That might be too small. But in that 1 megabyte, let's say it's 10 megabytes. Let's assume 10 megabytes is 4K. And so when you're downloading 10 megabytes on 4K, say your internet quality is really crap. So what it will do is actually download 10 megabytes of 320p video. And you're watching Matrix now in like the worst quality. And then your internet gets good. It like does a detection and whatever. Then suddenly it's just to download the rest of the Matrix in like 4K. But you can use that same logic for policy control, where you can say the next time it fetches, am I still allowed to keep watching this movie?
I see.
Right? It's very simplistic. There's a lot of little stuff that goes on there, but at a high level, that's what you're going to do. You're going to say, hey, I still want to watch this movie. And then once it like kind of loads, it stops loading. And this, you will see this happening a lot when you're dealing with live streams on YouTube, or you're dealing with like live events where something happens to the broadcast feed, right? Or the event gets taken down because it's like YouTube has all these like Bitcoin scam live streams that happens, and so the live stream is taken down. You're watching it and you're like, wow, it's still working, and they've taken it down. And your friend's like, oh, it's not. I don't see it online anymore, and then suddenly it stops, right? And that's because they just killed the content. So someone's streaming that video, but you're not going to watch it because the policy is like, hey, you got to stop watching it right now. So half the matrix never gets downloaded, basically.
Yeah, makes sense. Also, I had like one, I guess, potential solution is that if your license like expires before your license actually expires, you can just take it down from the actual platform, so like not
exactly. That's the business logic, right? Like that will always, if we were to explode the web app, what you would technically have is you would have the web app here, but it's first talking to a database, like your SQL database. And then the SQL database is talking to perhaps it's talking to an API. And the API is talking to, and say there's a microservice. So it's talking to a microservice that's called the policy or the rights and licensing microservice, right? And why is this font so? The rights and licensing microservice goes to like a database, and it goes to the SQL database, and it says, hey, uh, the user wants to watch the matrix, and are we still licensed to provide the matrix, right? And the SQL, there's a SQL flag somewhere. It's like, say, matrix false, right? Or it says false all, and then it says matrix true but only for USA, right? So something like that. So let's say if it's only true for USA, then it goes, hey, this user is in Canada. Are they allowed to watch matrix? And the database says no. It returns true for USA, which you could say false for everything else. So this guy says, okay, thanks, false. API says false, and then so when the user wants to watch matrix, it says, sorry, not available in your country, right? Or it just doesn't show up. Like the guy goes to search it and just doesn't show up in the search results.
Yeah, makes sense.
Yeah.
And I think before we move on, just a quick question in the chat. So similar to how you have CDN in different cities and regions, do we have CDN for each customer?
No. If you CDNs, think of them as file specific. You typically don't have files that are like, I mean, yes, of course you have files that are customer specific, but there would be no need to have a CDN for a user because those files are already stored in like a storage bucket somewhere, namespace by folders, right? So it's up to your business logic to be able to figure out, is this user able to access this file? The files will always be stored. Like right now, there's a Facebook CDN somewhere around, and on that Facebook CDN lives all bunch of private data for a bunch of users, right? Even though they live right there, me as Faisal can only access my own content because when I request it from the CDN, Facebook's getting that signed URL and giving me that URL to the CDN solely based on that I have the rights to look at it, right? So they sign the URL and do a whole bunch of systems, cryptography.
Yeah, makes sense. Cool. I think now either we can go back and finalize the video or
I mean that's how at a high level that's how the CDNs are working, and a lot of people actually don't know about CDNs because so much of it is transparent, but they're very useful once you start dealing with like large files, like actually exactly what Google said here, static content. Like forget movies right now. Let's imagine you have a JavaScript file, right? Why can say you're loading Angular or React, everyone uses React. Say you're loading React, right? When you have React, like the script tag, the React script tag isn't going all the time to like Facebook servers to go fetch it. It's living on a CDN somewhere, right? And so that's why your user could be in the middle of nowhere, not middle of nowhere. There's no CDNs there. Let's assume like in the middle of the US, like right in the center. There's a CDN nearby that they're able to use to grab the latest version of React because it's cached on that content delivery network. Right? And so same thing with the movie. That's why Netflix works really well as long as your internet's good, whether you're in India, Russia, Canada, China, like wherever you are, it will work properly.
Yeah. Cool.
Cool. So that's how CDNs work. So if we were to like high level think about where CDNs fit, right? I'm going to have this master diagram that we can keep up to date here. So we have the web app. Let's just say we have the web app here, and then we have an API, right? And actually, when we have the web app talks to obviously a load balancer. And then the load balancer is talking to, this is a very simplistic API, is talking to an API. And then the API is storing, it can talk to a storage bucket. The API will also talk to a CDN. And what is it doing when it's talking to a CDN? It's doing some stuff. It's basically saying um, something like delete file or say upload file. Technically, the files are usually transparently uploaded, but so you're not really doing upload file. I won't put that in. Clear cache. Um, what else would it do at a CDN? Uh, um, I think for now, let's just assume it's that, right? And then the CDN itself is talking to the storage bucket, right? And so what is it doing from the storage bucket? It's like fetching files. And then internally, the CDN, now this CDN is like Google CDN. So this is not even your code anymore. This is like a server. The CDN then is putting out all the files to edge CDNs. And so let's just assume there's a whole bunch of edge CDNs around the world. I'm only going to represent it by 3, and it's doing that. So now the final thing before we move on is the user wants to watch the matrix. And so this is essentially what happens. And we're going to follow it together. We're going to say, all right, user wants to watch the matrix. So the user clicks on matrix. So this request will just draw a request, will represent a request as a circle. So the user wants to watch the matrix. And the matrix right now is living in the CDN. Let's say the storage bucket here. Mm-hmm. Yeah. User wants to watch the matrix. So the API goes to the load balancer. The load balancer says, oh yeah, I'm going to go to the API. The API says, okay, you want to watch the matrix? And the API does, am I allowed to watch the matrix? Am I in the right country? It does all of that shit. And it goes, oh, okay, great. What I'm going to do is I'm going to this is what the API does. The API will create a signed CDN link. And the API is just going to get a signed CDN link verifying that this movie, which is on the CDN, or it will be very soon, let's assume, I'm going to grab a URL to it, and I'm going to send it back to the user. So the user it goes all the way back to the web app. And now the web app now has a signed link to access the CDN to watch this movie. Then the web app makes another request, and it makes a request straight to the edge. Because DNS-wise, it knows how to go to the edge. It automatically makes a request to the edge because of the CDN link. And so when it makes that request, and that CDN link, just so we all know how it looks like, it's probably something like cdn.google storage. Let's just come up with the URL, googlecdn.com/matrix.mp4. Okay, that's all it is. And it's signed, so it's like,
with a key.
Yeah, exactly. It's like key equals blah, 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 and valid equals like maybe has a timestamp, right? Some timestamp on it. And so it's all signed. It's very complicated. And so it makes a request to the edge. Let's say this is the first time, for whatever reason, it doesn't have it. It goes, okay, I'm going to go talk to my CDN papa here. And so it goes, hey, CDN, do you have it? The CDN doesn't. It goes to the Google Cloud Storage bucket, grabs that file, and then that comes here. That gets replicated to all the edges, and it comes here, and then it goes, okay, you want me? I'm going to start streaming bits and bits. Let's just assume it's just streaming bits in it. It goes here, and it starts watching. All that happens in it's probably like 300 milliseconds or something. Because of how fast the networks are. So you're essentially making 2 requests. You're making a request first to get a link. Once you have the link, your movie player, whatever that movie player is, takes that link and says, it's time to play a movie. And then the movie player makes a request, and then it starts to get bits of the movie through however the media streaming is working, and it starts to playing the movies.
Mm-hmm. Yeah, makes sense. Yeah, I think it's a great summary of it. Yeah.
Cool.
Just 2 more questions that we have in the chat, very quick before we move on to recommendation engine. So Are CDNs storage scalable, or is there a memory limit which will wipe the older cache?
Really, I think it really depends on the provider. I don't think there's any limits on the delete the old cache. It's just how much you can pay, right?
Mhm.
How much? In fact, I will tell you guys this much. This happens in Canada. I'm sure it happens in the U.S. I don't know about other countries. I would guess it does. Some of these edges, these edge PDNs we're talking about, not only are these like, say this actually happens with Netflix, it happens with Facebook too. I'm assuming it happens with everyone just because it happens with one. Facebook, so we have in Canada, we have a large telecom provider. We have a monopoly, it's a big scam. But we have Rogers and Bell. And what happens is um, Netflix has made deals with Rogers and Bell to to basically they've given them physical servers, or Rogers has set up servers, and Netflix pays for it, where movies are cached, so that when someone makes a request on the Rogers network, instead of it having to go to anywhere, it goes straight to the Rogers network because everything's going through Rogers anyways because we're on Rogers network, Bell's network, and it downloads the file right? And so that's how advanced this stuff gets. Now, again, this stuff gets advanced when you're dealing with a billion customers. Right now you don't have to think about it. That's why 99% of people are using Google CDN and not like a Rogers CDN that only Netflix or Facebook have access to.
I see. I see.
Yeah.
Cool. Then I guess to quickly cover the next question is, can if content isn't available on a local CDN but is on a nearby one, will it serve from there or the main server? So like I
Yeah.
guess in this case.
Fantastic question. Yes, it will. All of them have a lot of really interesting capabilities where internally they will be like, hey, I'm in Toronto, because the game here is how do we limit the distance? How do we increase speed and limit the data transfer? If I have a CDN in downtown Toronto and a CDN in Scarborough, and for non-Canadians, they're like an hour away, right? So instead of it having to go to like America to get a file, it will go quickly and it will say, hey, downtown, do you have this file? It'll be downtown, will be like, yeah, I do. They'll grab it. There is a great CDN service called Fastly. Fastly powers the internet. That's what their branding is. And so if you look at Fastly's CDN, these guys have, let's take a closer look. Look at how much CDNs they have here, right? Oh, that's pretty cool. So if I want to zoom in here, oh, I can't actually zoom in here. Okay, but take a look at this. So they got a CDN in New York. They have one in Ashburn. So like Toronto, Detroit. So like imagine Columbus needs a file. It can just talk to Detroit, Toronto, Ashburn. That is so much faster than it having to talk to, for example, somewhere here, Portland, right? And they have a legend here. There's planned upgrades, new pops, and multiple pops, single pop. So there's like actually in Chicago, Fastly has realized that hey, a lot of traffic, there's a lot of customer demand in Chicago, right? So we should get multiple edge CDNs there. So when you deploy a file, your file can be distributed across. There's not a lot of traffic here, nor maybe Fastly doesn't have, I don't even know what country that is, right? But maybe Fastly doesn't have the legal requirements or legal licenses, whatever, to operate in this country. But this country, say they wanted to download the Matrix, they have a couple choices. They can go straight to Johannesburg or Cape Town, yep, or go to Accra to download. Their Matrix will download slower, assuming everyone has the same internet speed, which likely not here, but their Matrix will download slower than someone who is in Milan and they want to watch the Matrix. Their Matrix will download a lot faster. Even if it's not in Milan, it's going to be in Marseille or Rome or Palermo, and it'll just be like, bing, let me just go grab Matrix.
Yeah, makes sense. Yeah,
And
that is.
Cloudflare, Yeah, Cloudflare CDN network. I mean, let's see. There's there. Can I see a quick map? A network map. Yeah, like this is. Oh, this is Google's network. Perfect. I thought it'd be hard to find this, but here we go. Right, like this is Google's. Oh, this is just network cables. Oh yeah, see, I don't know where that is, but Google has a similar diagram. I'm sure you can find it somewhere. This is Cloudflare's diagram. So Cloudflare's gone crazy as well. They look at all this. This actually tells you a lot about how the internet operates. Like clearly, there's a lot more internet users on this side of the world than somewhere right here, wherever whatever this is, like top of Russia. I don't know where this exactly what state that would be. Obviously, a lot of Indian users. China doesn't have a lot of. Yeah, where are we here? Yeah, I think that would be China. Anyway, China doesn't have a lot of CDNs because China has a lot of firewall policies and all of that stuff. So they're doing their own. China does have a lot of CDNs. What I mean is Cloudflare doesn't have a lot of CDNs in China. Not a lot of people do there unless you can work with the government.
Yeah,
So
yeah.
that's how it works.
Cool. I think just to be mindful of time.
Yes.
So I think we dedicated the majority of time to video storage and streaming, just because I guess it's like the core of
Yeah,
Netflix.
exactly.
But then we have two other ones like recommendation engine and personalized content generation. If we can like dedicate maybe
let's do that.
minutes to each.
Yes. So let's do recommendation engine, right? So recommendation engine is interesting, and we'll stick to this diagram, this master diagram we have here. So now let's say we have two users that want to watch. We have two people. Let's say there's three people. So first we got Neo who wants to watch a movie. And then we got Morpheus who wants to watch a movie. And lastly, I wonder who it will be. Obviously, Trinity Matrix, who wants to watch a movie. All right, cool. So these are our three users of our app. And we could do it one also. I mean, we could do it with two people, but it makes more sense with three. We have an image of Trinity horizontally. Okay, we'll just use this image. This is perfect. Okay, whatever. All right, so guess what my favorite movie is, guys. All right, so we have three users on our system. And these three users are watching a lot of movies. So they're watching a whole bunch of movies. I'm going to represent movies with just stars for now. So they've watched, there's three movies here. Red. Oh, a terrible color. Green. I apologize to someone if you can't really make out these colors, but let's just assume there's three different movies here. And actually, to make it easier, I'll put 1, 2, and 3. Okay, there. All right, so there's three movies here, and I'm watching them. I'm getting them served via CDN. So Neo comes on first, and Neo watches the first movie, and it does all the CDN stuff, and it comes back, right? So now somewhere in the database, we have a database here. What we are going to write is Neo watched movie 1. Great. Then Morpheus comes on. Morpheus watches a movie, and he watches movie 2. So it goes, there's the whole CDN crap, and he's now watched movie 2. So now Morpheus watched movie 2. Fantastic. Okay. And then we have Trinity. Oh, actually, Morpheus watched movie 2, and then also Morpheus watched movie 1. So Morpheus has seen, Morpheus watched movie 2, and Morpheus watched movie 2. So now Morpheus watched 2 movies, Neo's watched 1, and now Trinity comes on, and Trinity's like, all right, I want to watch a movie. And Trinity doesn't know what to watch. Like so Trinity just sits there and just randomly says, uh, you know what? I'm gonna watch movie one. Okay, so Trinity goes and watches movie one. Great. Now Trinity's like, I want to watch another movie. Trinity will now have an option. I mean, without any recommendations, Trinity will have an option to watch because Trinity has watched one. I'm gonna put it down just so we keep track of this. And there's a method to why we're doing all this crazy stuff. Watched movie one. Okay, so Trinity wants to watch a movie. Now, what Trinity can do is either just click on a movie and watch it at random. So Trinity hasn't seen two or three, or get a recommendation for a movie. How are we going to recommend what movie to watch? So there is a very basic algorithm called collaborative filtering. Collaborative filtering. What collaborative filtering does is it goes to the database. Imagine this is a SQL database. It could really be any database. SQL is actually a lot easier for this, so make use SQL. Um, and maybe we're using like AlloyDB here or Postgres. I could talk about AlloyDB. Well, it's a SQL database, and what it does is it says, okay, from all the users, what's common among people who have watched movie one, right? So it will say, well, people who have watched movie one, and it'll look at Trinity because Trinity wants to watch a movie. It'll say, who else has seen movie one? And it'll say, well, Neo watched movie one, Morpheus watched movie two. And then it will say, okay, what else have they watched? And it'll say, well, Morpheus watched movie two. And it will tell Trinity, hey, Trinity, you should go and watch movie two. And Trinity goes, oh, okay, that's an interesting recommendation. But Trinity watches movie two now. So now that Trinity's watched movie two, it is, if Neo were to come on, he is guaranteed for sure to see a recommendation to watch movie two because now not only has Trinity and Morpheus watched movie one, but they've also both watched movie two. And the only thing Neo hasn't watched is movie two. And so at a very, very high level, that's how collaborative filtering and recommendations are working. Now, we're only looking at one thing here, which is watching a movie. That's it. Netflix and what you can do to make your recommendation engine better is, did I like the movie? So this is based on watch. But what about like? Right? So you can then take into account Trinity watched movie two but hated it, right? But Trinity watched movie one. Morpheus watched movie two and loved it, right? So now when we go to Neo, we actually don't have enough data, but assuming we had a lot of Neo's likes and dislikes, we can say, you know what? Neo is a lot more like Trinity because Neo has liked all the things, even though Neo, Trinity, Morpheus have watched all the same movies. It's actually that Neo and Trinity have liked all the same content, except that Neo hasn't watched this new thing that Trinity's watched. This is the simplest, but also most effective way of doing recommendations. Now, we're talking about watch and likes, but imagine you start getting into a lot more crazier stuff like how long did they watch, right? Did they? You can try to get hyper personalized, and that's what YouTube does. Where it gets kind of annoying, where like you accidentally click on one stupid video, and now your entire feed is filled with stupid videos, and you're like, God damn, right? That's because YouTube, for the most part, at a very simplistic way, saying, well, if Basil liked this stupid video, he's also going to like this because other people who saw the stupid video also like this video, right? And it just gives me a chain of recommendation. Obviously, the recommendation algorithm is a lot more detailed, but at a high level, that's what's happening. So you create a database and you store all this data. You keep putting it in, and you try to log as much as data as possible. And you write a simple always to start off with collaborative filtering. And there's so many libraries that do it. There's probably even Python collaborative There we go. Python collaborative for building library. Yeah.
I guess you define, like in simple words, you define some metrics that you care about that would be definitive, right?
Exactly.
Watch time, or maybe how many times they actually watched the movie, right?
How many times? Yeah. Exactly. How many times? See, in this one, they're doing e-commerce. So same thing with e-commerce. Recommendations are recommendations. Movie or you're buying shoes, it's all the same shit. So in this case, he's talking about how many times the customer bought something, right? And then they're just writing some code around. We're not looking at code. We're just looking at high-level architecture. But that's what you're doing. You're gonna create a database. The simplest way is to do it in SQL. I mean, you can then write some Python code. So let's just say you have let's put in something here called recommendation microservice, right? So in your recommendation microservice, I don't know why it's red, but in your recommendation engine microservice, whoops, right? In your recommendation in microservice, every time a movie's watched. So if we go to movie, every time a movie's watched, you're storing that data, right? And that data is logging it to SQL. But then at the same time, you also have the ability to ask the database and say, hey, let's write a SQL query that whenever the user wants some like a new video recommendation, tell me what's something that the user hasn't watched yet that similar users like him have watched and liked or disliked. So don't want, not dislike actually, just like, watch, rated 0, how many stars, 3 stars, 4 stars, 5 stars. And there's a funny story, and I might get the story a bit incorrect. The high level of the story was Netflix had a competition to say who can come up with the best recommendation engine algorithm. And they found something, someone won the competition. It was a really powerful recommendation algorithm. But the urban legend, and I believe this is now an urban legend, is that Netflix still ended up using some form of collaborative filtering because it just worked so well, because they had so much data on their users. I'm curious to see what Netflix's algorithm now is, because they're able to use machine learning to analyze videos, because you can get pretty intense. You can say, they don't like action movies, but there's action movies and action movie. There's Matrix, which is an action movie, but then there's also Expendables, right? So what's an action movie? So you could do an algorithm where you can say people like this movie and it had a lot of blood in it. Neil liked this movie, had a lot of blood in it. So these two like movies which have a lot of blood in it. Let's recommend him more movies that have more blood in it, because we've been able to analyze that content over and over.
Yeah.
Make sense?
Yeah, that does.
Yeah. Okay. That's collaborative filtering. Now, what you eventually do is you want to make sure there's like a cache in front of it, because you don't want to keep running this expensive query over and over again. So you would put like a Redis cache or something on top of it. Now, there's also easier ways to even do this. Google has something called the recommendation API, right? That you can just use recommender. There's an API. Let me actually go to the service. Oh no, wrong one. Recommendation. Yeah, Google Cloud Recommendation API. How can I there we go. Yeah, recommendation from Vertex AI Search. So this won't be, actually you can probably use this. Yeah, recommended for media. So recommended media. So look what they're doing actually, funny enough. Recommended media content, articles, videos based on watch history, optimized for goals like converting trial subscribers or growing ad inventory. So their optimization, what they're looking for, not just based on people that watch, but have other people who have watched it go on to pay, right? So their system gets more advanced. So if you read the documentation, you can implement this. You can actually get rid of, instead of the recommendation microservice, you're now going to tie into Google's Google's recommendation API, right? So you don't have to write any of the SQL queries anymore. You're just writing your database, but then that's because you always want to store this data. You never want to not store this data.
Mhm.
But you're also sending this data to Google's recommendation API, which is storing all the data on their end, and then you're asking Google, get me recommendations, and here you're storing data for recommendations, right? And if you look at Google's recommendation API, you user events. Here we go. You upload user events to personalized recommendations. So what are user events? Watched, liked, converted. Did imagine you were offering a trial subscription. So imagine Neo's a freeloader. Neo doesn't want to pay right now, but we serve him the right content that Neo goes, wow, I love Netflix. I'm going to go pay for it, and watches everything, his recommendations, blah blah blah. But now when you have like a third user that joins, so imagine this is like a new user that joins. This speech bubble is a user. Now, when this user does very similar things to what Trinity, Morpheus, and Neo have done, we're going to provide that user content that Neo watched before he converted into a paid user. And you can kind of get away with all that by just using the recommendation API that Google provides, or you can build it yourself if you don't need a lot of complexity.
Mm-hmm. Yeah, makes sense. And
Yeah.
I think also like an important thing to understand is like all of those like tools, right, and concepts that we talk about. There are, as you pointed out throughout the session, there are already libraries and like services that are already built
Yes.
for it. Essentially, it comes down to you understanding the concept, right? So what we are covering here, and then bringing it all together, right? So this is
Exactly.
like
The key is don't reinvent the wheel unless there's a specific need to reinvent the wheel, like write your own recommendation algorithm. Use Google's recommended API, or don't use it. Use a Python library that's open source that ties into your SQL database. But you have to understand why you need it, what the pros and cons are, right? And that's the whole purpose of this. Like now, I hope a lot of people understand why you would use a recommendation engine. I mean, everyone kind of knows, but like how it kind of fits into Netflix and how it's all working together.
Mm-hmm.
Yeah.
Cool.
So the last thing is posters, right? And custom. And so it's actually very similar to this, which is great. Is on one hand, we're talking about showing Neo some video to watch, right? But what about Netflix does this a lot actually. If I go to Netflix right now and I see all the freeloaders on my accounts using my Netflix account, but then I scroll down and I look at, let's say, this poster. Actually, let's look at this poster, Hitman. Okay, so this thumbnail, forget the poster, this thumbnail. If you were to go on Netflix, chances are this thumbnail is different for you. And this thumbnail is different for you. Netflix does this. I believe Prime and all these guys do this because this thumbnail could just be the movie poster. But what Netflix wants you to do is watch content. The more you watch content, the more money they will make. And so, what Netflix does, and it's exactly similar to recommendations, is Netflix goes, Basil clicked on this. Basil would actually click on this and read the description. So they in their database they add a log and they go that movie poster triggered Basil to click on this, right? Like whatever reason, maybe Faisal saw that this is about like two people who had a gun range. Faisal likes gun ranges or something, so Faisal clicked on it, and then okay, interesting. Did Faisal click play? If Faisal clicks play again, that's double. So now they're gonna find users like me, and they're gonna say, you know what? Let's try it again. Let's give another user that has similar stuff that Faisal's watched in the past. Let's serve them up this thumbnail, right? And let's see, will they click on it, watch it? And if they do, then we have a new thumbnail that we're going to use. So how are they generating these thumbnails? There's a couple of very interesting ways you can use Gemini or ChatGPT for not Gemini, sorry. What's the Google image generator? Whatever the hell it's called. Google Gemini image. It's called.
I think it's now integrated into Gemini, or no?
Yeah, they have a exactly. Generate images using AI. Yeah, image gen. There we go.
Okay.
Very boring. So what you could do, imagine you were doing something like this. You could take movie posters and you can start to, instead of recommending movies, you're already doing that, but you can build another microservice here and you can call it image poster generator. Poster generator, right? And your poster generator microservice, your poster generator microservice can go, okay, let me tie into the recommendation microservice and see what movies, what does Basil like. So now we would have something a lot more detailed. We wouldn't just have watched movie because that's not really telling us much about what poster to generate. But we have stuff like Basil likes gore, horror. Basil watches movies with Keanu Reeves, right? And so the next time we recommend, actually, I don't know what horror Keanu Reeves, so we'll just say sci-fi. So Basil likes sci-fi. Basil likes movies with Keanu Reeves. And so the next time we recommend a movie, right, we have two options. We can go, we can recommend Faisal two posters. We can recommend Faisal a poster that is, let's go poster. Let's find, yeah, we can recommend Faisal this poster for Johnny Mnemonic, which, I am recommending a movie and this is the recommended poster. Or I can recommend, because I know Faisal likes it, I can tell ImageGen to take a picture of Keanu Reeves and create a very unique poster that, maybe because it's all science fiction stuff, I can create a completely new poster. This typically doesn't, like Netflix isn't actually creating new posters. What they are doing is they're taking different elements of a movie and they're slapping on text. Like, this is not a poster for a movie. This is a scene from a movie that they just stuck on the Hitman logo on, right? But let's just say we're getting crazy advanced here. Same principles apply. I can create using ImageGen or Flux or one of these image generator services. I can create a poster of Keanu Reeves because I knew that Faisal likes sci-fi and Faisal likes movies with Keanu Reeves. So I get a poster, and instead of serving up this poster, whatever that poster was, I serve a poster with Keanu Reeves' face. And that way, I am more inclined to click on it and watch that movie. And then I track it back into my database. And I just loop that over and over again till I, end up creating posters that are very, very interesting to me. And I'm like, wow, this is amazing when I watch this.
So essentially, maybe to summarize it, there are, let's say, 200 different posters, which are screenshots of specific scenes, right? And then essentially, depending on the user's preferences, or like whatever metrics you collect, like in this case, you said you like Keanu Reeves, right? So Netflix would go and find a poster
a scene?
that has Keanu Reeves. Yeah.
Exactly. A theme, and Netflix would find a scene, so they would use, and I was going to show another image generator service, but Netflix would go find, they would have like a video analysis service. So the video analysis service would say, video analysis service. And it would say, find random photo of Keanu Reeves in Matrix. Or say, this would be Johnny Mnemonic. And then we would find it and we would say, let's just say slap on logo on this photo. And it would just show you that. And that's the movie poster is created. Now, the reason we brought up ImageGen and this AI generation is because now that we can create really custom images, there's a service called Flux Realism. So I can say, a movie poster. Now imagine you were to fine tune your own or have your own poster generation. A movie poster with Keanu Reeves. Uh, I can't spell Johnny Mnemonic, so how do I spell it? Is that how I spell it? Yeah, perfect. Uh, that's Johnny Mnemonic. Make the poster exciting and science fiction with Keanu Reeves front and center. So now I've used this microservice. I'm generating a poster that Faisal likes. Bam. It clearly doesn't say. Have the text say. It didn't have. Oh, clearly it's not generating with text.
Mm. Yeah.
But technically it would. Maybe this Laura one, this realism one doesn't. Yeah, but imagine it just had text. Or you could just slap on text, right? And I'm like, wow, that was cool. I wonder what that is. Now, when it comes to movies, you probably the studios will not like it. But if you're building a video service like a YouTube clone, there's nothing stopping you from doing this, right? Or if you're generating your own, it's very possible to do all of this. Let me try one more. Let me try this. It says, I'm gonna try this. I just want to get it working, just as an example. Just very clear. Yeah, it doesn't work. But anyways, that's what you would do, and you would get that poster, and then you would display that poster.
Mm-hmm. Yeah, makes sense.
Yeah. So if we go back high level, right? Like we're loading videos, all these videos, and when we click on something, and when we hit play, just to like kind of summarize, when you hit play, a couple things are happening. First, it's going through the CDN and it's grabbing the video, right? And it's giving me the link. It's also inserting into a recommendations microservice saying, Faisal, watch this movie. And then it's also tracking it and it's saying, well, why did Faisal click on this poster, right?
Mm-hmm.
And it's saying, okay, well, Faisal clicked on this poster. And I see this all the time. Like you can see on the side here, there's a poster of all three of them. But sometimes it will just show me a poster of like Trinity or Morpheus. And we'll see, am I more inclined to click on it? And then it will use that as data for other movies that I'm showing. Like right here, 300. That is not a poster for 300. They just used the scene from the clip when Leonidas is going for war. So that's what they do.
Yeah, and then similar like text and all the other content that goes in. So yeah,
Exactly. Cool.
Yeah. Great. I think there is like one question generally about resources, like books or anything like about system architecture, like high system design, like overall maybe something that had helped you learn all of this. I know that it's mostly experience, right?
Yeah, I think that's the key. So I would say books and stuff are good. And you're gonna find a lot of YouTube videos and blog posts about this if you just search something. But what I would say is what we talked about here is something that you can build with your own, like if you have 20 Google videos that you've recorded, or not, you know what? Go to like YouTube, download movie trailers, and imagine you're building a movie trailer service. Download 20 movie trailers. This is what I would recommend you do. Download 20 movie trailers and create a Google Cloud Project account and follow this exact approach, right? Use whatever Python, Golang, whatever you use, but use a CDN, right? Put all your videos in Google Cloud Storage bucket, use a CDN, and then follow this loop to watch a stream of video back, right? Use a video player. The most popular video player is JW Video Player, I think. Yeah, and I think there's a free version. Hold on, JW Video Player free. Yeah, there's a free version of it. Exactly. It's gonna have like a little logo, non-commercial. It doesn't contain the same features. Exactly. So download JW Player. What is JW Player? It's just literally a video player, but it has all the really nice features like subtitles and all that stuff, just so it looks professional, right? So use JW Player, or you can just use the video tag. but usually loop there supports streaming as well. And then so once you have that, right now you have that built. Then work on a recommendation service. Just simulate 5, 6 users, get your friends to view it, and see if if 3 of your friends have watched similar videos, will the fourth friend or fourth random person get recommended the right video? And that's the best way to learn. Just implement it, because as you're implementing it, we've only touched. We can sit here for like 5 hours going through this. I've only scratched the surface and left out some detail, a lot of detail. But as you run into it, try Googling it. These days, I mean, you can go to ChatGPT or Claude and sit there and be like, what is the best? Like, my recommendation algorithm is broken. What's wrong? And get it to like tell you, and then go implement it. Most of the time, they'll tell you the correct truth. Sometimes it will be wrong, but follow that loop. Um, Versus the books and stuff, because they're all good, but they won't give you the practicality to just like try it out. I've tried to be very practical here, so that you can at least just go on. Like nothing here, other than we said Google recommended API. Nothing here is Google Cloud specific, like or anything, right? You can go do this on DigitalOcean. I don't know if they have a CDN, but you can go do this and use like a CDN from Cloudflare instead of DigitalOcean. So it's
Yeah.
all very agnostic.
Yeah. Yeah. Also, I just want to clarify, like, that don't feel like you have to, that you have to build a system after watching like this. It's just like, as Faisal said, just a high level overview to familiarize you with the concepts. So then you can go on your own and, like, for example, like new things that we learned today, right? Maybe like edge CDNs and like collaborative filtering, right? And then on your own, you would like research it more in detail and build like some toy projects, and after you do this multiple times with different, I guess, examples, then you will get more and more familiar, and you'll acquire like that skill set, right? And this is like essentially what this series is all about as well. We want to take like real life examples, real life apps that you are familiar with, and then explain how it works, so you at least know how it can be applied, right? We are not just on one
the same concept.
Yeah.
The same concept can be applied to like a TikTok clone. Literally, you can use the exact same stuff. TikTok is even more crazier because the next video is the recommended video. So you're hitting that recommendation microservice every video to say, give me the next video, give me the next 10 videos, right? But it's again collaborative filtering at a very high level. TikTok's algorithm is crazy. It's like crack cocaine, obviously, but at the end of the day, at a high level, this is exactly what they're doing. You got a load balancer API recommendation service. Now the recommendation service is doing some crazy stuff, but imagine if you were to build TikTok right now, just use collaborative filtering to start off with and see how it works. And you'll find that it works pretty well. And then you can keep optimizing on it when you get more data.
Yeah. Cool. Yeah, I think no more questions in the chat, and I think we are almost time. So I would say that, yeah, first of all, like, Faisal, thank you so much for joining us, and for the great talk and overview of everything. And yeah, to all of the people who joined us and will watch us, thank you so much for as well. And yeah, please subscribe to our YouTube channel, or if you are watching YouTube or LinkedIn as well, and you will be notified when we post like another session. But yeah, generally, again, the idea is we want to have like multiple apps covered, and we already have like a few other apps. Our community has a few other apps in mind as well. So yeah, we'll keep you posted. And thank you so much again, everyone. Enjoy your weekend, and yeah, see you next time.
Take care.